what does it mean, a digital twin, in context of the underwater port terminals which you focus on?
Most of people working with digital twins just come to the point of the scanning, but digital twin is more to it. It should be something that you can make prediction of anything in the future, and by that you are in most cases using sensors. So if you are going to make transport, understanding how transport is moving in some port or somewhere, you will bring some sensors to the trucks and understand what will happen. But the real thing about the digital twin, as it comes from, I think, from the industry 4.0, it is prediction of something that is going to happen, to make analysis and to make predictions of some cases that maybe you will not see in the real life. And by digital twin, it is also going in different directions. You know, by NVIDIA is growing the Cosmos project, and then you can make prediction in our cases with the big waves and try to act on the structure and with the winds and everything. So it can be really huge data set. But basically, always you need to properly capture the first input, the real data that we are seeing.
2D is against my religion.
Mm-hmm. So basically, we can say that only the 3D mesh or whatever output you have from the reality capturing on itself is not the fully digital twin. Would you agree? It's like the stupidest LOD of the digital twin. Could we call it like digital twin zero or?
Yes. Maybe we should mention that we have now like levels of digital twin, 0, 1, like this is something that maybe somebody can quote us in the future, but this is nice thing. So it is always, the scanning is just a 0, 0, and then later it can be but probably you and I, we didn't see so many digital twins. We heard a lot of stories about digital twins, but real digital twins, it is way of mind setup for the client that needs to cover all the data in one huge picture.
Your niche is port terminals. Tell me, what is important to look for? What is important to monitor? What sensors do your clients usually use?
It is huge. It can be to the level of the least important sensors in the port. It can be humidity sensor in a toilet. You can also monitor if somebody spilled water in the toilet. But you can have the real data, like temperature sensor in a trafo part of the port. Or you know that more and more ships are coming from LNG, from heavy fuel to the electricity, and now you have to switch. You have to charge the boats, the ships. You need to charge them, and the temperature is really important parameter now. So any kind of sensor you're getting from the asset manager software, from the not only the sensor but also the data that was past data, it is great to have it, because then with this data you can make some predictions and make the digital twin help you in a real case scenarios.
Mm-hmm. Maybe it would be the right time for showing some of your videos, because I'm just amazed and jealous at the same time every time you post something out there, because your videos are just amazing. I'm sure your audience is happy as well when they see it.
You can, if it's not problem, you can showcase the video number 2. So you can see it is real data with a drone and real data with the multibeam echo sounder. So this colorful scheme between the flat walls and the real data, photogrammetry data on the scale. And now you can see also that we can predict the real data of the sea level, and also predict the higher level volumes, what are going to happen. But also in this digital twin, you can easily just drag and drop big cruise ships, 100 meters, 200 meters, and then you can easily make the mooring out of them. So you can move them in the ports, and then the sky is the limit. And something that we mentioned yesterday while we were talking, in preparation of this event, uh, everything can connect to everything in last maybe 1 month. It was really, really hard to do it in the past, but now you can connect everything to connect to everything. So this boat, it is a real boat, but it is 3D model, low poly 3D model of the boat. If you have eyes information where this boat is coming, you can give him the real coordinates. So maybe it's not in this port, it is going to be in some other port, but you can make predictions, and then you can connect it to maybe some Unreal or game playing, so you can predict the roles of what is happening with the people. So the maybe captain of the ship can understand the approach, the levels, the height, what is his vision, how can he work with the boat. So everything goes really, 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 really interesting, because you can connect all the data in basically game environment. And more that I'm thinking on this technology, the digital thing, I think that we are going to become the part of gaming industry, even though we are completely different industry.
Mm-hmm. When we were preparing, you said that Michael, you have to ask me about why we do this. Like what is the focus? And I have this answer. I hope you're going to give us. I have this connected to one question. Why are you using reality capture data? Why are you using 3D meshes or outputs from lidars instead of just simplified beam model or some CAD model or whatever data is available there?
Yes, but we can adopt BIM models to any kind of port, but this is for the maybe for developing of the port, for understanding what will happen in new areas or something like that. But if you have real data, for us, ideal situation, we have a client in Croatia that is called Port of Rijeka, and they're eager. Every day they call us with the new ideas, and sometimes I'm angry with them because the ideas are, it's hard to develop, you know, but they have always the new idea. What should we do? Should we do this and this? And we started to follow not only their energy, but also started to follow our way how to showcase them that everything that we collected and make the 3D model of can be really, really easy adoptable. And so when you ask me why not 3D poly, low poly 3D models and everything, imagine that you have a drone that flies itself every day. You can make 3D models. It is hard on the data side. Probably you will have terabytes and terabytes of data. You have to be careful what kind of 3D model you're going to connect and everything. But just imagine if you are a port operator or port authority and you want to understand what is happening daily in your environment, and you have drone that is flying out of the box. You don't have to take care of it. It will just open itself, see the environment around itself, measure the wind, measure the rain, fly out itself, send the data. Luckily, you now can send easily data, make preparation, and then everything connects real data in real 3D model daily. And this is something that is stunning and also necessary, because you don't have to send the people on the site to look somewhere, oh, please go on that side, because the ports are not small. They are kilometers and kilometers, and then sometimes it is hard to go there. We are now starting, but the end is not far away. Not far away. How to explain it? Technology can be connected on different level this year than it was in 2025. Unbelievable, unbelievable. So you can easily, something that we already did for many, many years, it just in 2026, it just blew itself, because LLM models is helping you to make texture, to make, like my friend says, that English is the best programming language right now. You can easily connect any data to any data, and you don't have to have a software engineers that you had to need in the past.
But let's get back to 3D meshes, because my actual question was aimed to, like, what level of detail do you actually need on those data? Why are you focusing on photogrammetry underwater?
Okay.
Because
In
we all know that it's one of the hardest things to do, right? With photogrammetry in general. So
Yes.
Why do you need?
Yes, the real answer is, there is always fight between port authorities, who are in most cases, or the state owners of the asset, or the port, and some companies that use this port for many years. So they, the port operators doesn't need to be owner of the port. And then there is a fight between those two, and the fight is about port authorities would like to have asset properly managed, and to have the everything prepared, a lot of rehabilitation work and everything, while the port operator sometimes doesn't see it as idea. So why we are gathering such amount data in underwater photogrammetry? We are following the cracks through the time shift. So if we did inspection in 2020 and in 2025 and 2030, or maybe with a little bit less the time increment every 2 years, we can follow up what is happening with the cracks and what is happening with the concrete or the steel, and we can follow up what is the date, not the follow up, we can predict what is the date when the structure will collapse. And this is important. What is the minute minus structure collapse of some structural point? And if we can predict that, then the port operators can use it regularly, but also port asset owners, as a port authorities or the state, can know what is the amount of money needed to be invested, so they can later use it if the port owner finish the contract and goes out. And this is the crucial. In most cases, it is crucial to follow up the state of the structure and understand what is happening with the structure. And for that, if you're doing the photogrammetry, in most cases in underwater, it is concrete or it's steel. In some cases you do the timber, but in most cases there are two materials. Then you have to have people who are different approach. They cannot be just machine learning specialists or YOLO environment people or software engineers. You need to have the people from biological stuff who are working on the biological and also chemistry, because then you can see what kind of shelf is attacking concrete. Is it lowering its stability? Is it happening something? And also on the corrosion. So it is not only by vision experts, it is more on understanding what is happening with the real structure, and then making the prediction based on visual that you can do in most cases.
Since we are speaking about the cracks in the concrete and the corrosion, which video should I show to the audience so that they have better idea of the
Okay,
level of detail?
I think you can show this Victor Lenat's. So you can see it is 300-meter long dock. There is interesting story about this dock, because it was built up in a Second World War, and it was floating in Pacific while the Second World War was, and it was meant. It was developed for the. It was developed for the purpose of fixing American ships who were attacked by Japanese Navy. So they bring it to the Croatia 30 or 40 years, and they just make the anchorage, even though it was made for the floating. But you can see now in the video, you can see that there are huge mooring system downside. Just to have the perspective, it is done in a BIM. It is around 9 meters long, 9 meters of height. So it is around like three-story building, and every of these is needed to be inspected properly and to see what is happening with the connection of the steel to the concrete structure, because this mooring system is concrete structure. And then you can see we just placed the person who is 2 meters tall, just to understand how huge is this and why do you need to follow cracks or to see what is happening, because you have concrete structure which is 9 by 9 by 9, which is huge, full of the concrete, and then you have to connect it with a steel chain that goes 45 meters up. And then on this side, you have also the problem with the with the corrosion, but also you have some floating currents that become and may destroy the chain. And it is important to understand what is the level when you do the grade photogrammetry, what happened, and can you make the time shift inspection on this side to see are the you know, the chain is strong as its weakest link. So you need to check this weakest link, what is happening with them through the time shift series.
Mm-hmm. I think it's time to go to the part where we will discuss the different ways how you can capture the underwater scenes, and especially to understand why the photogrammetry workflow is so difficult, and how do you fight with this.
Yes, you have this video. You can share it. It's called LinkedIn Plotchetry. It is PLOs. You will see it is a lot of piles. I
Yeah.
think yes, this one. Yes, I think this is the hardest job that we did in a past. There is more than 200 piles. Diameter of this pile is 1.5 meters. It's huge, even though it doesn't look huge in the video. But we also needed to make multi-beam inspection of the slabs, and also do the photogrammetry by diving in and then diving out and connect everything in a 3D space. And you know, you did the photogrammetry in the air. Making the photogrammetry in underwater is extremely complex. You have so many different variables that you need to take care, and you need to understand what is happening, because you have salinity, you have turbidity, you have the reflections on the dome. Dome gets deformed, and every little bit of variables attack your photogrammetry or SFM procedure, and then you get the curvature. And it's formally known, people know it in underwater, know it, it's called banana effect. It is basically curvature of flat surfaces that are not becoming flat. You can easily overcome this challenge if you have ground control points in the air, and then you can check, or you can have RTK precision with drone flying. But when you're in underwater and you have curvature like piles, then it becomes really heavy. And it becomes heavy also when you have different technologies approaching. So you saw in the video, colorful scheme was multi-beam, basically multi-beam data, which basically means it's ultrasound done on wide areas, and then you got just the points X, epsilon, Z without color because it's ultrasound. And then you have to connect it with the real photogrammetry data that is not just the piles, but also the slabs from beneath. So you have to dive in with the ROV or USV drive. And we didn't have luck on this project, so we have to dive in beneath all the beams and then dive out, and you don't see what is happening. You have to have a lot of cameras and everything. It's extremely hard to connect three different data sets from different equipment, because all of those have its own error, and you're bringing error to the question. And
Do
mostly
you
when we are
are you in any way using classic targets, or how do you control these data sets?
well, there are so many different approaches. We know that our algorithm is working properly, but for our clients, because they like to test it later, we sometimes get array in underwater just to prove them that our procedure was right, not only in data collection, but also in post-processing. So we will try to make, how to say it, I always like to talk the story about my daughter making me believe that she is ill, and she takes the thermometer, you know, the old one, and then she said me, I asked her what is the temperature you have, she told me 37.1, which is the reason not to go to school, you know. And then if I take it, it is 36.9, you know, it is the scale, but it depends where you look at. If you bring it up, then you understand me, you will see 37.1 if you look up. If you look down, then you will see different temperature. It is same with the photogrammetry. It is based, you have to understand what are mistakes in your measurement, keep them out of the picture, and make repeatable inspections on known environment. And from that we didn't want to develop the tools or the methodology for the data acquisition. We wanted just to buy equipment, and there are few producers of photogrammetry underwater tools. We talk with everybody, and we just ask them, okay, we believe that your equipment is strong, it works properly, you have great data sets, everything is okay, but can you show us a large scale portfolio project? And apparently, except us, that you're heavily in 3D, you are scoping, you have great conference in Prague, that by the way, we are going to be there in May, am I right? What is the date for the conference?
Yeah, it's going to happen on 5th and 6th of May this year in Prague. You all are welcome. If you want to check the conference, I will bring up the banner here. So it's called Free Dice. All the information is at freedice.com. Early bird tickets are still available, so make sure to go there and secure yours.
Last
Thank
year,
you for the commercial break.
no, I didn't want to make it a commercial break, but for me it was interesting last year when we went to the Prague, that everybody who is game changer in the 3D scanning and everything was there. So you managed to have everybody there, and for me, on perspective of underwater photogrammetry, there was not so many people working in that area. You understand me? And basically, when I was there, the TED started the presentation. TED from NIRA, he started the presentation. There was Arash also, and I was like amazed what great data sets are there. And I saw that maybe there are not so great data sets also in the air, in cultural scanning. So at the conference, we had more than few people to talk, but it is not big community, and you can imagine how small community is in underwater. So we asked everybody, can you show us the portfolios? And nobody couldn't show us the portfolio. At this moment, I can showcase you the portfolio of, let me say, I can showcase the portfolio of 7 kilometers of flat walls up to depth of 20 meters immediately with RTK precision, just opening the NIRA. So you understand me, when you start to work with the underwater photogrammetry, it is just about portfolio, and you need to understand that buying the equipment won't solve your problem. It is just about the procedures, understanding what happened. And in our case, we had a big luck getting the equation done pretty fast, maybe just 3 to 4 years.
The reason why I was asking about the control of the data acquisition and then processing is because at the video, and I could put it out there once again, we can see a long line of the very similar environment, repeating environment, and this is a terrible environment for the photogrammetry because usually the software has no idea where in this long line it actually is, right? So how do you tackle this?
1 million photos. It's like, I think the project was 1.1 million photos. But how to say, for us, it is not a problem because we understand that the Microsoft Excel is not the software that you should write text in. It is the software for the numbers. And people, in most cases, they do with the photogrammetry differently. We understand where we take the photo and how we're going to give her this photo, not only just coordinates. So our photos become X, epsilon, Z by information where they are, and they also became pitch roll
But
yaw.
sorry,
So
but how you somehow collecting also RTK information or
yes, we have different procedures for different stuff. If you're doing just the blocky walls that are flat walls, then we have always WMU instruments and also RTK precision on the pole that we are acquiring the data on.
Hmm.
So for when we are diving in and diving out, then we are doing some information on RTK that is outside and inside by measuring speed of sound, so we know what is the location of our ROV.
Okay. Okay. Perfect.
And for the piles, you need to understand dynamic light and how to make procedure to work around the pile, because the piles you just show us in video were huge. They were around 1.5 meter in diameter. It's huge. It seems in the video that it's not huge, but it is huge.
What type of
Maybe it is.
cameras are you using? Because I think I have seen also the video that you were using 360 cameras also for these use cases.
No, no. For us, the type of the camera is not important. When we make the calibration parameters on the dome and on the camera, we can use GoPro 7, 12, 13. What is it? Any kind Insta. If we have luck, but it is not like that. We can use the full frame cameras because then you have better dynamic range, better lenses. But you have to know, we are gathering so many data just from one reason. We keep it stupid simple. So if we can have a GoPro on the site and be near to the construction, we will probably use it more than we should do the full frame cameras. Even though the full frame cameras,
You are mentioning the dome. What do you mean by that?
dome is something that covers the camera, and it helps you to have wider angle of picture you're taking. But the dome needs to be specially casted. You cannot buy it on AliExpress and expect it to have great results, because it will, even though it by its mean dome will not be stressed on the forces that is appearing on it. It gets deformed by the depth where you're putting the equipment down, and this is like small pieces that just goes like up, but it changes the parameter, and then the SFM software cannot relate on that. But when we know the parameters of the camera, we know the parameters of dome, we always use the special cast domes for our photogrammetry. And then when you know the salinity, when you measure the turbidity, then when you have the lights, it depends on the location. Even though people think that the beautiful coastline and really clear water is good for photogrammetry, whoever did the photogrammetry underwater knows that the zebra stripes appearing on the shallow water up to 2 meters in Maldives or maybe in Croatia, wherever you think, Bali, it will kill the photogrammetry model. So the zebra stripes, that everything that goes from the sun and then goes on the small waves, and then just every frame you take is different zebra stripe on the bottom, and it's killer for the photogrammetry. You have to understand how to move it out of the picture. So this is the reason why it is the hardest thing to make the photogrammetry. It is the underwater photogrammetry. It is the wave touch zone. So where the waves are, maybe half meter or meter beneath, or half meter above, because you have so many changes of environment in that area that is really hard to make it. So just to know, if you're doing the photogrammetry in deep offshore business, or you're making photogrammetry of Titanic, it's easy. It's not easy to bring the equipment to the 4,000 meters, but from the perspective of photogrammetry, you have stable environment at 4,000 meters. Nothing is happening, no waves, you understand me? No change of the light. You are the only one who is bringing the light to the scenery. So maybe some fish with the, that has light in front itself, but there is no light. And for that deep operation, photogrammetry is heaven for photogrammetry, because the light conditions are great. It's not easy to be done because the depths are high, the pressure is big, but everything the rest, it's so easy.
Maybe to clarify, so the reflection and the refraction of the sunlight in the water or on the water, that's one thing, but you are saying that also the streams, underwater streams and waves can also cause a different distortion of pictures, right?
No, not distortion. It will give you the wrong information, 2 pictures that you take on the same site. So if you have 2 seconds between two, if you have the picture in the same location, you took 2 pictures of the shallow water, let me say coral reef, and 1 meter of depth, you take 2 pictures from the same locations. In 1 second, you will have completely different information on the picture, because zebra strikes from the sun will completely change the picture.
It's time to show some video again.
Yes. Or maybe I can showcase our biggest project, so you can see what I was telling you right now. So maybe this
You
touching
wanna
point.
show
Yeah.
the Nira?
Yeah. Yes.
Meanwhile, I will mention that it's going to be shown on Nira app. It's from Arash Kaisami. You certainly know him. That Strasimir is also part of it. He's very well known guy on LinkedIn and on YouTube. So this is the platform where we as well showcase all of our biggest data sets from 3D scanning or 3D meshes.
Okay. The touch zone. Let it call the touch zone. This location here, where you have the underwater photogrammetry model, but and the above water photogrammetry model. It's so hard to get connection on this site, and you can see we have an overlap in less than half of centimeter. There is no gap here, so it's not easy to be done. But you can see somebody threw up here the fishing net, so they're trying to catch the fish. But when I said you that it's not easy to be done, I will just zoom out and I will show. So if I give it the sea, it will be looking like this, okay? And it's huge. From this location, from point here to point here, it is around 4 kilometers, maybe 3 kilometers. So it's not so, but the great thing about also Nira and how we can represent, we can bring up the inside the picture, we can bring up the beam models. You can see there is a beam model of the crane, of the structure, but there is a crane that was done in real 3D photogrammetry model with the drone. But also we can jump to the locations, and you can see we integrated also the new bridges that are going to be part of the port. So it is, you can see photogrammetry model, but also beam model here. And then I jump just maybe a kilometer on the other side, and I'll try to zoom it. So I'm now zooming to the minus. It is minus 10 meters, I think it's showing now. So you can see, but also I can measure volumes, I can measure everything. So Nira is a great tool also for all of our clients. We just push to them, and I will calculate the volumes on vertical just to see what is the volume. Oh, it went in a different direction. I need to orientate the plane differently. Just a second, I didn't do it properly, but you can measure the volumes of missing part and everything. I just make the calculation on the wrong point, so I have to change it. But to have the opportunity to measure 7 meters of something in underwater and in real 3D model while jumping from one point to another point, it is unbelievably lucky to have it. But also you can see there are vertical walls. Somebody made tires from it is most cases, the people are using tires for the bumpers, not the real bumpers on the site. And then I can zoom out and zoom in to some other location to showcase uses here. You can see now I go down. You can see we had a gap here. And even though it seems that this huge gap is only 1 centimeter, two different approaches on the. So the unlock with the great 3D model is that you can easily see mistake on a measurement point. But I
Okay,
just jumped.
but to be clear and to explain this to the audience, datasets below water and above the water, they need to be separate datasets, right? There is
Yes,
like
yes.
zero chance to get accurate data from under the
No,
water above or the other way around, right?
no, it's not possible. It is different. So at this point, there are many datasets, but 3 major: above water, below water, and then multibeam data that is this colorful. So you can see this is low on this location. It's called low data set on multibeam ultrasound. And here we have a better data set. So you can see something that is, you can see it is a little bit better. But if I measure here, just to have the perspective of measurement and everything, I will just measure it here just to better understand it. It is 7 meters. It's not small.
Mm-hmm. I wouldn't discuss the accuracy because I just suppose that also multibeam is connected to RTK always, so
Yes.
the data at itself is accurate. But I'm wondering about the level of detail, like what resolution does it have? Let's say in 10 or 20 meters, what detail of the data can you get?
You think about multibeam or the photogrammetry
Yeah,
data?
multibeam.
Multibeam. We push to many clients and many partners. I just have one partner in Norway who really understands what our needs, and I think he's claiming that he can do resolution 2 by 2 centimeters, but I think he can do it 1 by 1, but he doesn't want to showcase it. So they're great. They know a lot about ultrasound, especially ultrasound that is on a near shore and on the verticals. So the ideal you can, I know we had a few projects with a 2 by 2 centimeters, and they managed to make 1 centimeter by 1 centimeter, but they are claiming it's not possible. So even though they did it. So.
What does the hardware do? Why do we call it multibeam?
Multibeam, it has array, it has array. Maybe I can connect you on some other podcasts with the great guys who are working multibeam. It has array of ultrasound array that comes from one point, let me say like area, small area. It is beacon. And from the beacon, in most cases, you have 1024 beacons that are like laser beams, but they are ultrasound, and they come back from something they hit, come back, and then with a strong software, you can easily understand: is this backscatter data? Is it data that went from different points? So they can have a better result in lower depths, you understand me, and with higher frequencies. But it is not my part of expertise, so maybe I will say something wrong with the multibeam. But from my perspective, it is just the boat or a vessel that has pitch rolling understanding, and it measures the speed of sound, and it also measures the everything. So the results can be really great, and it's usable in high turbidity waters, which are in most cases above 50 NTU. So the visibility of 50 NTU, it's not so strict like that, but the visibility of 50 NTU, turbidity of 50 NTU is around 1 meter. So if you have particles and you go to the structure and you will see from 1 meter, you will see the structure. If the turbidity is
Do you have
higher, then
do you have any hard limits on uh, what visibility you can actually work in?
we claim that 50 NTU is our limit. We can work in higher turbidity waters, but then it's not visible for us. And you have to
Okay,
understand
okay,
our
but for regular people, what does it mean? Like from how many meters you can work? The visibility on
one
5, 10 meters.
we can work in 1 meter. If
Okay,
if the visibility is 5, then it's great.
above reality capturing is pretty clear. Okay, we have options like photogrammetry, we have options like terrestrial laser scanner or slam scanner or airborne lidar or airborne photogrammetry, or maybe something more, doesn't really matter. But what about underwater? You have showed us the photogrammetry, you have showed us multibeam. What other ways how to capture the reality underwater? What other ways there are?
For underwater,
Mhm.
well, fine, you can do the video and you can do the picture, but for 3D scanning, it is
I was
just
hoping for 3D
that's it.
data.
You can do the light. You can do also the lidar. It depends on the type of the lidar, but you can go. You can make the different approaches with the ultrasound. There are some ways that you can do it from the space, but all of this data is like flattened later. It's not real 3D. Maybe shallow water lasers are working properly, but it also needs to have a great visibility.
I just wanted to add that I have seen several technologies claiming that they are able to use laser beams underwater as well for the scanning. What do you think about it?
If I could have a budget for the scanning with the laser, I would really gladly use it as a technology to prove myself that it is okay. But you have to understand, with the laser, it is same with the ultrasound. The same. You lose the color. So with the ultrasound and the laser, you have just X, epsilon, Z information. And with the photos, you have also RGB, red, green, blue. So you know what the point represents. And then sometimes, you cannot use multibeam data on shallow waters in 1 meters. You cannot approach it by the boat. You understand me? So there is a limit with the hull keel of your boat that is bringing the multibeam to the location. But there is also, in that cases, if you have great visibility and you have large areas, you bring the helicopter and laser and you will get the great data. But it will not get you the information of what type of structures. You will get just the shapes. And there is also something that is great with the multibeam data. In most cases, people who are using the multibeam, in most cases, they are using it for the hull clearance approval. It is more on the maritime business, so they need to know what is the depth and how the keel of the boat is going to act on that. Is there 20 centimeters of free? So in Suez, that evergreen boat, I think it was stuck in when it closed the Suez a few years ago. It was stuck, and beneath the boat, it was maybe 30, 40 centimeters. So the ultrasound data is more on the side of what is happening with the bottom. And when we think about it, it is great if you use the data on multibeam, which is called backscatter. It is data that just goes through the, let me say, ground and goes back. And I'm not expert, but you can have a lot of information on it. You can have the information what type of the soil is. You can have information, is there anything buried in inside, maybe some pipe or something. You can see that some sunken ship is below maybe first 1 meter. So the technology can have a different approach, like photogrammetry. You know that the photogrammetry is now drifting to 3D GIS, which is great. But I'm not sure still that, especially in underwater, it's still not the solution for the cracks. Not sure. Maybe I will change my mind in next 1 or 2 years, but still we are not getting the great results on that. In Prague, you will have probably more and more information on 3D GIS and
Yeah,
nerves.
this year we are going to focus on 3D Gaussian splatting with our free dice event. So our goal is to bring as many as good speakers as possible in this field. It's not going to be about the theory of 3D Gaussian splatting, because I don't understand it either. But
Okay.
the use cases are amazing, right? So what we want to
Yes.
show to people is what different possibilities there are, how to use 3D Gaussian splatting, where and how to implement it, what hardware, software to use, and just simply to show how the 3D industry is going to change or is already changing with the 3D Gaussian splatting. We have seen multiple big names in our industry to implement 3D Gaussian splatting. So when we were preparing, I also promised to ask you about the 3D Gaussian splatting. But as you mentioned, you are not satisfied enough to push it out and to.
We are not. We had so many tests and everything, but it is always when you're using some new technology that is stunning. 3D GIS above water, it is. You just imagine all the mirrors you can. With all the mirrors, there is no holes. And if you ever did the photogrammetry and you know what is the hole in any kind of steel, highly polished stuff, and then you just get holes. And with the 3D GIS, you don't have the holes anywhere. But in underwater, we are looking for the cracks. And even though the starting point, it is always the point cloud. we don't get enough data on the structure to have the proper conclusion still. So maybe my mind will change with the development of technology. We are trying to use new tech on the underwater, but still not sure that it is ready to be adopted in underwater. But I didn't think that the 3D GIS will come 3 years ago. We tried to first to use NERF 3 years ago, and we were like stunned how fast the technology developed. So it doesn't need to be closed topic, but at this moment we are not smart enough to have it properly to make workaround that is making proper data sets.
We are very soon going to discuss the not the business model, but the business use cases, and where are the money in this underwater scanning and underwater digital twins. But let's say that uh, your client doesn't really care about the newest technology. They care about solving their problems, and since you haven't seen 3D GS as a way how to solve them right now, that's the main reason why you are not
Yes.
using.
Yes, at this
Mhm.
moment, right now, we are not using it. For the air, it is great. We will adopt 3D GIS and overlap with the photogrammetry model.
Mhm.
For underwater, we still don't see the user case.
I'm interested in the process of the capturing data under the water. So is this with the scuba divers, or are you sometimes using like little submarines on, or how do you do it?
Yes, we have different approaches. We use it in most cases for our business model. It would be great to have ideal flat long walls. So like imagine the Great Wall of China and make it in underwater up to minus 20 meters. This is our heaven. So nobody else can make something that is flat become flat, or something that is a little bit curved become curved as it in real life. And we are at this moment the only one who we are aware of that are capable of doing such stuff in shallow waters. It means up to 20 meters. So also for photogrammetry above water, it is heaven when you have things sticking out of the picture. But when you're doing the flat surfaces, you will also have the problem with photogrammetry if you don't have some kind of RTK or GNSS or some ground control points that will help you organize your or data, or in best case some kind of inertial navigation unit that will help you understand where you move. Sometimes you can
We already
you
mentioned the banana effect. It's the
yes.
very same for the above ground photogrammetry.
Yes,
So.
yes. So for us, ideal it would be to have we have tools on the 15-meter carbon poles with a two-camera system, and we have two inertial navigation units, and we have data loggers. We are logging also salinity, turbidity. We are logging the parameters. We are logging what is the depth. We know the parameters, how to use it, and then you have person, maybe in future robot, that just plays down the pole, and it goes down, goes up, then moves 1 meter, goes down, goes up, and it's rather stupid procedure. And we keep it like that because we are working in different ports around the world. But if we need to collect the data on 20 meters of depth on a breakwater, which is basically covered stones or some kind of structure, then we are using small ROVs, which it is a small class ROV that is maybe battery powered, it can be electricity powered, but it is basically drone that doesn't leak. So the technology is the same. It has more engines differently adopted. In drone, you have 4 engines in most cases, and we have 8. So we don't need to use the verticals to go up or move the ROV to tilt it to go up, because drone will go like this. So basically we are using in most cases handmade tools for the verticals, and sometimes we are using ROVs or USVs, which are above water, same like ROV, but it doesn't go beneath the water level.
Mhm. How do you prepare for a scanning session? Because if we are scanning either with the scanner or we're doing photogrammetry, we always will look for weather, whether it's going to rain or snow, or whether there is going to be a fog, or whether there is going to be a heavy wind. So what are you looking for when you are preparing for the scanning day?
Uh, if we have a luck to have great scanning day, for us it would be uh, cloudy day, completely cloudy day without any waves and any wind, and without rain. So this is the heaven for us. So
Just
cloud
to
day.
clarify this, it's the same for the above water photogrammetry.
Yeah,
Again,
that's it.
when there is sun shining, it's not good for photogrammetry because you have a lot of shadows, a lot of exposure on white surfaces and so on. So
But you know that for when the cloud, you do the scanning in the cloudy environment, you lose some color, and it's the models are like they're not flat, but they became like you don't like to see them.
mhm.
Even though sun is worst, shadows are sometimes like sexy because you will get the better results.
You gave me a good way to bridge this question to the delighting. Are you doing the delights on your images, or you are using raw images from the capture? How do you work?
Oh, it depends on different projects. We are using it differently. The most important thing is that we collect as many photos as we can on the site, as many we can, because we early found out that the problem with the data is not the quality of photo; it is when you are missing some data set. So when I told you that we are using the keep it stupid principle, we start the camera system to make the photos and then we stop it. And in most cases, we have 40% of photos that are not important for the reconstruction, but we then erase it automatically when we get to office. So
Hmm.
we found out that if the technician on the site doesn't start the camera and makes the inspection of 1 hour and then sees that he didn't do it, it is the worst case scenario. It is even worse
What
than
what's the biggest project? How many pictures did you take on a biggest
the
project?
biggest. The biggest project was the one that I show you. It is 1.1 million on the one side, but we have the project that is even bigger, but it was done through many sessions. So maybe I didn't see it, but I think we are around maybe 15 or 20 million photos on that project. When I try to collect the sessions from the different time, and the reason when we are talking about accuracy, I wanted to mention, but I forgot it. Uh, we cannot. Oh no, we can, but it is not wise to be because you cannot fake the results on the accuracy level because we will come back in 2 years, and if we did something wrong today, it will kill us in 3 years. You understand me?
Hmm.
So, for us, understanding the accuracy, how to make everything proper, it is crucial to be on the highest accuracy that we can achieve, which is, and the highest accuracy, I'm telling you, the level of this accuracy, it is more uh, to be on the side, uh, not to go to many terabytes with the accuracy. You understand me? So you have to have some point when the accuracy and the level of data you're acquiring goes bizarre with the data sets in terabytes in a storage. So we try to move it to be optimized, but always overscale the project.
Hmm. Before we jump into business side of this underwater digital twins, we should show something again. You have
Yes,
beautiful videos,
maybe.
so just tell
Yes,
me what to
yes.
pull out.
Okay, okay. But I have also one project that maybe can basically understand. The people can understand what is the time shift. Okay,
Hmm.
and the accuracy that we achieved. So, if you give me opportunity to again present, this is the project that we did 1 year ago. It is huge above water photogrammetry, below water photogrammetry, overlapping measurement, everything like the same that we did already. But when we started this journey on underwater photogrammetry a few years ago, we did one of the first projects here with the accuracy that is not on the level that is today accuracy. And you can see the data here with the multibeam. You can see the multibeam data here, but you can see the data on the walls and everything. So you can see they did the rehabilitation work on this side. But the accuracy from the first project and accuracy from the second project were not the same. The level of accuracy just goes up in the project that we did a year ago, and you have to understand we developed the technology. But even though it was not on the level of that we would like to have it, I have this stunning feature from NIRA. You know, they made the compare feature view. It was maybe a month or 2 months before. So you can compare two results and see what was renovated when, and you can see they bring the shore up. So they build a new shore above water. So everything is higher than it was before. But you can see here, this is the location they made a renovation. I can erase maybe this one, and you can see it looks like this now, and it looked like this before rehabilitation. So this is the reason why we are trying to make as great accuracy as we can, and because our clients will later ask us what we did. And in this case, it was done between two inspections. It was done for the measurement of used concrete. So they spend a lot of concrete making it looks like this.
Mm-hmm.
But also this digital twin is great for the port authority to understand how to work on that and how to. So you can see the port was like this, and now it looks like this. So I will stop sharing.
Nice, perfect. So here's the big question: where is the money?
The money is in. Yesterday we had a talk about it, but you stopped me and said you should make the real story when you first told it in a podcast. The
Because
money is in
I
this.
hate this when preparing for the conversation. I hate this because we always touch with our guests the most important things, the most important stories, and it's very difficult to relive them, right, during the live podcast.
Yes.
So that's why I stopped you. Like, I don't want to hear anything else. Let's do this tomorrow.
And yes, the real answer is not something that people would expect. It is also something that our engineers are not understanding properly, even though I would like for them to understand. It is all about the needs of the client. So you cannot just sell the raw data. We never thought that we are going to be integrator of this technology through Unreal. Maybe this Unreal is going to be our future. I'm not sure. Maybe it is going to be Unity, but this is something that our clients show us and said, "This is everything is great. We like the data. We like everything, but can you help us understand how we can move in underwater and make decision on the data?" And bringing them just raw data, it's not important for them. So we needed to adopt multibeam data, the technology that we are not using. We needed to adopt the drone footage that in most cases we are not using, and we need to adopt many sensors. We have to adopt new technologies. We have to adopt ice information on the vessel, where the vessels are. If you go on the webpage Vessel Finder, then you can see whole world, wherever time the ship has its own beacon, you can see how it's moving, and it's becoming our 3D model. But we also had to adapt the meteorological sensors and also adapt technology that are still not polished to enough, like NVIDIA Cosmos, which is great for, let me say, you make huge scanning of big areas with a lot of trees, and then you make wildfire on it. So you can predict with the wind when it's going to be. And still, I think that nobody in above water is not using it like that. Even though the clients are claiming this as a service, not the 3D model, not the laser scanning of the woods. They would like to know what is the burning power of the area because different type of the trees, maybe some something that is building in woods in Mediterranean, it fastly burns. You know, it has its like, you know, there we call it Cheshire. It is part of the of a tree that is full of some kind of oil, and when it's in the fire, it will explode and rapidly open the fire on a location that is maybe 500 meters because it becomes the rocket with its own fuel. And the question you ask me, where is the money? If you just listen to your clients, you will see the needs. If you see the need of the client, and client will be really, really nice to you and pay because they need the answers. So the real answer in photogrammetry underwater, we needed to switch to time shift. And this is one of things that a few years ago, before this compare tools that you just saw in NIRA, I was talking with Arash while the NIRA was small company. There were just few of them, and ask him, make us compare feature, because without that, there is no, they didn't know how to explain him what is that. And he said, do you mean time shift inspections? He just blew up the word that we are using for 4 years later. So our clients are really, really interested in time shift. They're not interested in data gathering, accuracy, precision. This is something on us. And then we have many projects that I cannot communicate now because new stuff is building on our 3D models. So if you think about Vectrino, what we are again on the same page where we were 5 years ago when we wanted to make the underwater 3D models. We just adopted technology. We understand how technology is working, pushing it through our licensing partners so the licensing partners can work on that technology through the world. We give them the methodology, how to work and everything. But the major thing is that we are going to talk with our clients and understand what are their needs. In this case, people didn't understand that Unreal is the future of their environment, and all the digital twin is going to be in gaming industry. If you ask me,
So you're
I think this is
no, go ahead.
if you ask me, I think this is the future, and I didn't think about it 4 or 5 months ago. I really think that the gaming technology. I think the NIRA is also on the page of gaming technology because it's so fast. You can zoom to the levels, whatever. But how to say it? And if you ask me, if we had this meeting 15 days ago, I wouldn't understand how greatly LLM just went into our business. So language learning models are growing strongly, not just ChatGPT, Gemini, or Grok. It is adopting process that we don't need software engineers. No, we need them, but not on the junior side. You know that you had so many great ideas, so many great ideas that you needed to talk with the software engineers, and they stop you in development because of they are not understanding the technology, what your needs and everything. And with that, with the development of LLMs on local machines, now it is growing fastly.
Who is your customer? We mentioned that you are working mainly with the uh, port terminals, but are they your okay? Different question. Who orders your data or your analysis, and who has to pay for it?
Okay. There are two major way of contracting our works. First of all, it is great port authority or owner of the asset who really understand that they need to inspect a asset. So in most cases, they are owners who are responsible. You have the ports who don't think that this is not, they don't think it's important to make regular inspections. But also, in our case, they are not our formal buyers, but they push the operators or the company that is responsible from some area to make proper inspection. They are insurance companies. So insurance companies are pushing the operators or somebody who is working on some area that they need to make proper inspection and they do not need report on the data. And this is something that is completely different, because for us who are gathering data, sometimes it is great just to sell the data, not to have some kind of report or integrate it in a digital twin. Or so insurance company said to the port terminal operator, okay, if you want to have the lower premium on the price of insurance, make the proper inspections and give us the raw data. Give us just 3D model and we will decide is it going to collapse or not. Because if you give them the great data, the great data sets, they will easily, in platforms like Nira or something like that, they can easily look at it, decide, okay, this point is not good, not good. And then price of the premium for an insurance goes up because the structure is not stable or it needs to be checked more. And if you check it more and make proper inspection, then the insurance company said, okay, we are free. Nothing will happen on this structure. There is not collapse. It is not collapsing on the known data. It may collapse on unknown data, but for them, it is crucial to know the real data. And this is switch from the digital twins. You know, the insurance companies just want raw data to decide themselves, their teams, the people who are working in insurance companies, like the one responsible for the insurance of big terminals, they want to see the data by themselves.
How do they know how to read those data or how to understand them? Are they people from the field, or they just learned
you,
it somehow?
you will
Or
you would be amazed how many people in insurance understand the structures. So you have great engineers working for the insurance or inside the insurance companies, understanding maybe some process better than its own owner. So I had a few scanning jobs when I saw the guys coming to the location, bringing from the insurance, bring their own pressure gauges to mount them on the process to see if the gauges of the owner are not modified. So you understand? It was really interesting for me to see that they are really good at the topic they are trying to make insurance on.
Mhm. Nice. I was also wondering, how often do you think is important to do rescanning of the board?
It depends. It is risk assessment. We have a client. I just got a message who is listening now. I cannot. I got a message on WhatsApp with thumbs up. They have a special terminal when they have a lot of boats coming on daily basis, and you know the boats have propellers, and the ground it is like small gravel. So when the boat touches the construction with the propeller, it it is like pressure washing. You understand me? It just push the small particles on the construction, and then construction is attacked. Concrete is attacked by a lot of small stones. So they decided they are going to follow it every year. But if you don't have
Mhm.
such type of so if you have a great terminal, let me say, you have a big cruise terminal. You know the cruise ships they have this azipod. It is propeller that can turn 360 degrees. So they turn the engines depending should they go by side, go forward. They change everything. So the amount of the force they push on the structure where they are moving out, so they're ships from 300 meters, when they are moving outside from the point of mooring, from the coast, it is huge. So on this structure you need to have it regularly, maybe every season, before the season, or do it regularly, because you will see small movement that you have to spend not so big amount of money on rehabilitation. But if you leave it for 3 or 4 years, then it's going to collapse, and then you would have another project that is going to be so much on the paying side.
What do you usually see on a side where you can like say, okay, this is going to collapse in like few months or 1 year or 2 years? Because we are not speaking about days, apparently, right? We are speaking about longer time and
It in most cases it is the inspection of the slabs underwater. So slabs that are in splash zone, where the waves are pushing the concrete, and then when we have the steel inside the concrete, it is always it is the major problem. In deep underwater projects, you don't have this problem. You can have problem of some deep for the steel structures. Maybe there is electricity, there is no cathodic protection. They're placing the electricity inside to protect the steel structures for ionization and everything. But how to say it, in most cases in the project in behind me, there is not such a case because it's full structure. But if you have piles and you have slab that is also splashed by the water, it is always in that zone. And you can, by the look of the project, you will see where the waves are attacking the most. You will see
Mhm.
what part of structure is. I can maybe share the project just to understand what I'm saying. Just give me
Please
a
do.
second. So you can see the project. It is 730 million triangles and around 80 gigapixels of textures. Just needs to upload. So in most cases, it is with structure on the piles, it has its own advantages and disadvantages. Major advantages, you don't have this problem with the concrete and the maybe propellers or everything that is pushing it. But you have another problem because you have the slab from beneath that is always not in the water. So I will show you here. Here there is the thing that I mentioned. You can see already concrete steel coming out of the concrete, and it's necessary to make regular rehabilitation on this. But if you see it from the side, then you see it is on the first zone of waves. Such a structure here, it doesn't, there are not so problems here. You understand me? So it depends on where the waves you have it, but not on such a level as it is on the wave zone there. So
Mhm. Uh, we were discussing yesterday also the problems of the port terminals and the problems of containers, and what does it actually mean for the client if something happens and they have to stop. Maybe we can also show the video of how such a port looks
yes.
like.
So this is in Unreal, even though it is the real model. You understand me? So
Mhm.
we also use the Velox technology to bring the people inside here. So just for the reference, I think that our engineer is coming. We do the scanning of him with iPhone in the office, and then uh, this our chief R&D engineer in the company, just to have the scale of the structure. So for them, it is all about, for the port authority and also for the operator, it is all about what is the time frame not to have the boat bringing the containers out and manipulating. If you have structure on these flat structures and everything, it's not so highly, you need to follow up the movement of the whole structure. But let me say, in great ports, in big ports, one day of not working terminal can be up to 5 million euros. It's huge. So if you don't have it working for 100 days, it's huge amount of money. But I just blow up the amount of money. It can be 2.5 million or 5 million. It depends. It depends how many containers needs to be pushed to other ports, and then with different approach to come to the same location.
Mhm. So we were discussing so far all the analysis and the reason why somebody needs this. I'm wondering what's the like the core output from the Vectrino. Is it interactive 3D model with sensors, or is it model on Nira, or do you have your own platform? How do you deliver your projects to clients?
Always the project is on the highest accuracy. Always the data is always raw. It can be adopted to any kind of software, any kind of asset manager software, Nira, Unreal, Unity, whatever kind. When we get the great data, when we cover it, that it's in real coordinates in the GNS based environment, then we can adopt it in any software. But if you ask me what we are in the future, from 1st of January, I think we are gaming platforms. When I say gaming, I see also Nira as a future partner, because I see the Nira is also more and more going in IoT data. They understand the need. They have great team, the Arash, Ted, and the rest of the guys. They're small team, but really, really great. Like in yours, when we visit your conference, maybe you can pop up again 3 days. And, but when we visit your
This
conference
conference.
last year, yeah, just a period. But when we visit last year, there is maybe it. I won't be. It won't be maybe. It will be true. There is no more than 50 of us working on great projects in the world. Maybe there are some people who are not showcasing the results and everything, but how to say it? We were last year, all of us were there and at your conference discussing on the level of what is happening and everything. I think that this year again we are going to have an opportunity to discuss, because I think we are going to switch for our clients what is their needs in the future. I really think that 50 people coming to conference in Prague, or 10 people or 50, I'm not sure how many people are coming this year. Surely we are coming this year, but we are going to
It was over
switch.
300 last year, so
Yes.
hopefully
Oh,
more.
great. So, okay, but how to say, whoever is doing the scanning, and whoever, I think maybe you should also emphasize this in your podcast in the future. Please come to 3 days, not because of the topics that are going to be shown, because you can easily talk with the game changer in the industries. And then we can decide what is the future for our projects and everything. So if you ask me, we are surely gaming industry in next, even though we are adopting the data sets and the sensors and everything in environment, because
When you're saying you are gaming industry in the future, it means that all your solutions or analysis will be built on either Unreal or other gaming solution. Yeah.
yes, I was lucky enough to go with Thomas in Abu Dhabi last year, and we had the opportunity to meet Nicola from Unreal, and I was driving with her when going to the biggest conference in oil and gas business in Abu Dhabi. We were together in taxi, and it just blew up my mind when she told me, that all simulators in aviation are made on Unreal, and I was like, and there are so many buttons, connected to so many. So just one sentence in a right environment can change your point of perspective, and I think this is going to happen also in your conference. After the conference last year, we had a lot of changing in our. So maybe the answer is going to be after the May 2026.
This is very important point that you mentioned. It's really not only about the presentation and about seeing what the other peoples do, but since this is not Intergeo where you will have 20,000 people. This is not GeoWeek where you will have 5,000 people. This is a smaller conference with very high ticket people, very well known from LinkedIn and from YouTube, very skilled people, and you have amazing opportunity to meet them all and to greet them all and to speak to them. We have several networking opportunities. We have on the 4th of May, the evening before, there will be a VIP cruise on a river with an amazing opportunity to meet all the speakers, all the important people from big companies. So don't miss this. It's
Yeah,
going to be.
I know that it's hard for you to say the story about the 3 days because you are developing the conference from year to year and spending a lot of time understanding what happened. But it is crucial to mention that everything that we talk down there, it is like 3D scanning Davos. You know, it is it is like Switzerland with the
That's
important
cool.
people in 3D scanning. It's small Davos, small Davos. Let it call it like that. But how to say it? Whoever.
Let's not have Donald coming.
Yes, well, okay, but some important people will come. But the crucial thing is, whoever has a budget for the conference like this, whoever has it, and it is the most important if you're working 3D scanning or laser scanning or any kind of 3D technologies, beam technologies, or I think it is wise to come on the conference where the conferences are still young because you can easily get the data, you can easily communicate with the people, you can easily connect. So last year I just came to this cruise boat, just pop up, said hi, my name is, and then it started to the 3 days. Great place to be. And this is something that I am maybe using part of the podcast, but I really think it like that, and I think that people should come.
This is really great from you. I'm very thankful for this. Of course, I would be mentioning the 3 days conference, but hearing this from you, this all these nice words is really great. So thank you for that. And before we wrap this up, I would like to ask you because from our audience, there are certainly people that are from the service providers or facility managers or port operators or whatever is more or less connected to what you do. Can you tell me how they can collaborate with you, or how can they leverage your knowledge and your skills and your services?
Yes, I would be so happy if I in the company are going to work only 3 people. It's not feasible, but this is the thing that we are scaling in the future. We would like to have as less people and higher technologies. For when you're losing money, you have to bring the technology up. But we would like to work with our licensees in the future because our future partners are the companies similar to ours, maybe inspection companies that are working in some countries. They would like to have stunning technology down there, and they are going to be unique. So we opened more than few countries already with the partners who are working on our technology, or better, it is better to tell it methodology. Even though they get the equipment and everything, for us, we like just want to be support for our future clients who are doing the same, and then do analysis on the cracks and everything inside the house and develop such technology. So you just there is going to be new web in a few weeks up and running, maybe better explain the licensing procedure, how somebody can get it, but they have to be very careful with us because we are working in only 40% of the world seas. We cannot work in high turbidity water. So if there is a high turbidity environment, we are not the answer. The real answer is then multi-beams inspections, not photogrammetry. If the visibility is not good, we cannot do it. And we have another major disadvantage is that when we do the scanning and we do everything, we know the coordinates and everything, but I will try to explain it like that. We are more plastic than elastic. You cannot understand, is it something going to fall off? And diver can do it. So after our inspection, sometimes where we are not sure what is the happening with the structure, we just send the diver to the location, say go there and try to press it with the hammer. So, but this is same with the technology in above the air. When you do the 3D model, you are not aware what is the strength of some pole that is sticking on some building.
Where do you see Vectrino in let's say 3 years?
3 years. A gaming, but not gaming. Uh, highly understanding asset management, type shift inspection, prediction models using the game technology for environment because new guys who are coming are used to PlayStation and not serial and parallel ports that we all learned to work with in 80s. So we are old guys, even though we're greatly adopting new technologies, but new people are more, they're different than us, and we have to bring them the environment to them so they understand their natural, not our old way of scanning and everything. So you need to bring them environment to, so they understand and better move in it.
How does it work alongside also with the VR? Like these days, when you are delivering to client, is there an option also to see those data sets in VR goggles or?
Yes, without any problem. But in most cases, we push this later to the other clients. VR is at this moment. I know there are a few great companies that understand how to use technology. We can give the data sets, but we are not making add-ons. Even though we are using VR glasses, making we have ROV pilots, people who are using the small submarines to work, so they're using VR glasses to understand how it's moving and have a lot of info on their in front of their eyes.
Mhm. And maybe one last question: how are you leveraging these days, and how will you leverage AR or LMs in the future? How will you use it?
You think language learning models, how we going to have it,
Either
or
LMs
yes, yes,
or
yes,
AI in
okay.
general.
I just mentioned yesterday, maybe in preparation of this, uh, whoever doesn't know, whoever is in technology industry that we are using, you have to understand that everything that we knew, the STEM technologies, everything that we knew in the past, it just disappeared in the last 2 days or 15 days. Unbelievable. So, the guy who made the GitHub, he just tweeted yesterday or day before, my business partner, Christian, who is also coming to Prague with me. You have to meet him because he was one of the great guys, understanding everything. So, yeah, that pop up. He just sent me the tweet 2 days ago where the guy who is responsible for GitHub just said, in November, I was doing 80% of coding by myself and 20% of AI. And now I'm working in December and 80% of AI and 20% of touch-ups. And when people like who are changing the industry in that way claim such a thing and said, this maybe attack my ego, but it is like that. We have to early adopt it and an understanding because we are probably not so smart as them, and we are not on the topic. But whoever doesn't know that it will change, he's already late in development.
Hmm. Josip, it was great. You are doing amazing job. As I mentioned before, your videos are always top notch. It's very entertaining. As you mentioned, the business cases are not about delivering a 3D model. It's about saving and supporting the insurance of risks in millions or maybe tens of millions euros or dollars or whichever currency you prefer. So it's very important. Just a shout out, people, if you wanna get in touch with Josip because you see the business opportunity or you see the collaboration opportunity, don't hesitate. He might seem as a very edgy and very sharp guy online, but he's a very nice person and he will definitely speak to you.
Michael, yeah, I would like to just say one word at the last. I had this meeting today because this morning I had this medical issue with the head, and then I had a meeting in the office and asked the guy. Always great guys are like our communication. I really think that you're great guys that we meet online and everything. But you need to have great guys for working on great technologies. And at this moment. We have this engineer in the company. I asked him this morning to implement new sensor to digital model. And I asked him, can you implement it on it is like flag for the wind. I don't sure what is the right word in English, but you see it a lot of in airports and everything. And I asked him, can you make with the
White
wind?
orange or white red
Yes,
flag, right?
white red. And it is when you just have red, then it's speed of wind, and then you have two, then it's double the speed. But it has its own. And I asked him, can you make it in a digital twin in Unreal, build up that so we can have real information on the wind and everything? He's like, he stopped and said, I need time. And I said, but it's not so hard. You can make. He told me, but I need to bring textiles to. So he's already jumping to the making everything so much realer than it's maybe needed to be done. But you need to be around great guys. And thank you very much for calling me, because I really think that your team and you're a great guy. And thank you very much for changing the industry and for bringing new ways of presenting 3D stuff on a high level, and also on a funny and interesting level.
Thank you very much. Thank you very much for your kind words. Thank you, guys. Hopefully, Josip will come and answer all your questions. Thank you very much, guys. Have a great day. Thank you, Josip.
Thank you.